Welcome to the video for C1.2.2 where we're going to look at isotopes. So to start with, you need to find your periodic table and then use that to work out the number of protons, neutrons and electrons on each of these atoms that we've got here. So pause the video and then we'll go through the answers. You also, once you've done that, want to look at the last two, so copper and chlorine, and then tell me what's unusual about those last two. Okay, so hopefully we've found that beryllium, if you look at the two numbers, so I'm going to do it the way around that it's on your periodic table. So it's 9 and 4, and then sodium's going to be 23 and 11, fluorine's 19 and 9, copper's 63.5 and 29, and chlorine's going to be 35.5 and 17. So what we've got to remember here is that the number of protons is equal to the number of electrons, and that's equal to the atomic number, which is the smallest of the two numbers. And then the number of neutrons is the atomic mass minus the atomic number. So it's the difference between the two numbers. So for beryllium, the smallest number is 4, so that's 4 protons, 4 electrons, and then 9 minus 4, so 5 neutrons. And then sodium, so the smallest number is 11, so it's 11 protons, 11 electrons, and then 23 minus 11, so 12 neutrons. Fluorine, smallest number is 9, so 9 protons, 9 electrons, and then 19 minus 9, so 10 neutrons. And then copper, so 29 is the smallest number, so 29 protons, 29 electrons. And here's where we run into a problem, because that's going to give us 34.5 neutrons. And then chlorine, smallest number is 17, so 17 protons, 17 electrons, and 35.5, so that's going to be 18.5. Sorry, my points aren't very big. Neutrons. Okay, so what's unusual about these last two is that we've got 0.5 of a neutron. Now you can't have half of a neutron because it's a subatomic particle. It's indivisible. You cannot split a neutron in two. So how do we explain these numbers being different? And this is what today's lesson is. So we're going to learn about isotopes, and that explains why we sometimes have these numbers that are not whole numbers in the periodic table. So our learning objectives are to explain what an isotope is and do a bit of revision of working out the number of protons, neutrons, and electrons in an atom. So we've just done it as a starter, but just as a reminder, there's two numbers in the periodic table. So the big numbers, the mass number, the small numbers, the atomic number. The number of protons has to be equal to the number of electrons because atoms don't have a charge. And the number of neutrons is the difference between the two numbers. So lithium here has got 3 protons, 3 electrons, and then the difference between the two numbers is 4, so it's got 4 neutrons. So just do a bit more practice. I know we did it as a starter, but you're quite often asked in an exam to do this, so you can't do too much practice of it. So pause the video here, calculate the number of protons and neutrons in the nucleus of the following atoms. So you don't need to do the electrons, just the protons and neutrons. Okay, and then once you're ready, unpause the video and the answers will be on the next slide. Okay, so check your answers. So we should have, I'm not going to read them out, just pause the video and check your answers. If there's any you're unsure of, then just let me know. Right, so we need to copy this text into our book. So what is an isotope? So every element has a different atomic number. So the atomic number, or the number of protons, is what defines it as being an element. So every carbon atom is going to have the same number of protons. Every hydrogen atom is going to have the same number of protons. Every fluorine atom is going to have the same number of protons. But they can have different mass numbers. So isotopes are elements with the same atomic number but a different mass number. But in an exam, it's better to write it as elements are atoms that have the same number of protons but different number of neutrons. So this is the better definition here. And importantly, they've got the same chemical properties because they've got the same number of electrons. So if they've got the same number of protons, they've also got the same number of electrons. And it's the electrons that define the chemical properties of atoms. So the chemical property is going to be identical because they've got the same number of protons. So here's some examples from isotopes of hydrogen. So this is a normal hydrogen. So if you look in the periodic table, this is a normal hydrogen. So it's got both numbers are the same. So the atomic number and the mass number are the same. So it's got 1 proton, 1 electron. It's got no neutrons. So these are 2 common isotopes of hydrogen. So these actually have special names. So deuterium is hydrogen that's got an extra neutron. So it's, if you look at this, all of them have got 1 proton, all of them have got 1 electron, but this has got 1 neutron, and then tritium, which is the next isotope, has got 2. So this isotope is tritium. And so although they've got chemical properties that are the same, their physical properties are different. So they're going to have different densities because you've got extra neutrons in there. It's going to affect the mass. So the volume is going to be the same, but the mass per volume is going to be different. And the other thing that can change is these extra neutrons can make the nucleus unstable. So tritium, for example, is radioactive. So other isotopes you might come across. So carbon-12 is a normal carbon, but you can also have carbon-14. It's very important in drug discovery. We've already talked about hydrogen, deuterium, and tritium. And then this one links with a starter. So chlorine has 2 common isotopes. It has chlorine-35 and chlorine-37. So if we were to write those out, we'd write them as 35-17, and this one as 37-17. So if we remember from the periodic table from our starter, we have 17 and we have 35.5. So that 35.5 is an average of these 2, bearing in mind that it's not half and half. So chlorine is actually, so it's 25% of chlorine-37, and it's 75% of chlorine-35. And if you do the maths on that of averages, you can work out that the average, that works out as the average being 35.5. And then another example, a bit less common to be talked about, nitrogen, you've got 13, 14, and 15. So we've already talked about this. So sometimes the extra neutrons can make it unstable, so they can make it radioactive. So carbon-14 is radioactive, for example. Tritium, which is hydrogen with 2 neutrons in, is radioactive. So they might have different physical properties, such as density, but they're going to have identical chemical properties because they've got the same number of electrons. So what I want you to do now is, there's 6 questions there, and there's a YouTube video for you to watch. So if you watch that YouTube video and then answer those 6 questions. Right, so let's have a go at some past exam questions. So I want you to pause the video here and answer these questions. They're real exam questions. So pause the video and then the answers are on the next slide. So these were our questions. So what is an isotope? So an isotope is atoms of an element that contain the same number of protons but a different number of neutrons. And in order to calculate the number of protons and neutrons in these 2 atoms, so we've got here, we've got the atomic number tells us the number of protons, so that's 4 protons, also 4 electrons, and then 11 minus 4 is 7, so it's 7 neutrons. And then for this one, again, it's 4 protons and 4 electrons, and then 9 minus 4 equals 5 neutrons. Okay, thank you for listening. See you next time.